Virtual reality or simulated reality could very well be a possibility in the future. Instead of traveling outwards towards distant universes, humans will be capable of traveling inwards towards infinite possibilities, worlds created solely by computers where you can't tell the difference. A simulation, if you will. You may be surprised to hear that this could be happening sooner than you think.
Today, we have the technology capable of small-scale virtual reality, mainly used for immersive gaming. However, we have something bigger planned for the future. Robotics engineers are designing new and abstract ways to not just immerse your eyes into virtual reality, but your body as well.
Robotic engineers are highly qualified for enhancing virtual reality due to their broad set of electrical, mechanical, and software engineering. To solve abstract problems like virtual reality, you need abstract solutions.
Robotic engineers are creating wearable tech that allows the user to feel tactile sensations that originated within a digital platform. A robotics engineer's skill will help improve the overall feel of virtual reality by meshing together mechanics and software. In doing so, virtual reality will be able to support varied fields of education and architecture. How would one even begin building something like this? We'll run you through the steps required for a robotics engineer to solve abstract problems, such as developing virtual reality.
Using the daily work perspective of a robotics engineer, we will illustrate the steps required to solve abstract problems such as virtual reality. Surprisingly enough, engineers use something called math a lot. Math to an engineer is not just useful for developing, but is also vital for analyzing. The engineering method is the format at which engineers develop and analyze.
The first step in problem solving is fabricating a hypothesis on how to solve the problem. Once we have a possible solution, we can create a prototype to test our solution. One of a robotic engineer's greatest skills is being able to collect real-life data such as movement and position, then impose it within a coded data structure. Once within a coded data structure, robotics engineers can more easily use the normal distribution, better known as the bell curve, to analyze the solution for its viability. Such methods include hypothesis testing and determining probability given continuous data. Using such methods, we can indirectly determine the efficiency of specific electronic configurations and algorithms. Robotics engineers can also test their solution in software by plugging in artificial data. Because test cases use artificial data, however, we will likely not have a normal curve. Instead, we will use set theory, conditional probability, or even binomial probability to help create and implement test cases. Sometimes roboticists analyze trends to determine the best product.
Another useful way robotics engineers test a solution is with surveys. Surveying the general public yields results that can lead to a quicker development and more successful design. The easier way to analyze survey data is creating a graphical chart where you can physically see where the majority of customer needs lie.
Once we have gathered information using these varied methods, we can come to a conclusion on whether the solution is suitable or not. If suitable, we can continue with the final results, but if it is not suitable, we will restart with a new solution, beginning a new iteration to solve the problem all over again.